Hi students, my name is Ratnaprabha Patil. Today we are going to continue with your topic thermal properties of matter, and this is your fourth lecture. In last lecture we have started with the heat transfer, which means heat transferred from one point to another in the body in three different ways: conduction, convection, and radiation, in which we have covered conduction in last lecture, that is conduction, thermal conductivity, coefficient of thermal conductivity, thermal resistance, and application of thermal conductivity. Today we are starting with convection. So, what is convection? Convection is the mode of transfer of heat from one point to the another point of body by actual bodily movement of the heated molecules within the fluid. So, in liquids and gases, heat is transmitted by convection. So, convection is the mode of transfer of heat which happens in the fluid. What is meant by fluid? The substance or the material which can flow. So, liquid as well as gases can flow. So, liquid and gases we can call it as a fluid. And convection happens in the liquids and gases. You can see or you can experience this convection, or not, I can say experience, but you can observe convection when you can keep you can keep one vessel filled with water on your gas stove and observe the water up to its boiling. Then you will easily understand what is meant by convection is. So here again I am taking the same example. Water is heated in vessel. Okay. When we have or we kept vessel filled with water on a gas stove, what happens? The water at the bottom of vessel is heated first and its density decreases. As you know, that is, the bottom of vessel is having direct contact with the gas stove. Along with the vessel, bottom layer of the water is again contact with the bottom of the vessel, and it will heat, or its temperature will increase at first. So what will happen? The layer of water near to the bottom of vessel will get heated and its density will get decrease. And after that, what will happen? These hot molecules have high kinetic energy and rise upward in cold region. As density of this heated water molecules decreases, and its kinetic energy will get increased because its temperature is more than the upper layers of the water. Then its kinetic energy will be high. Then what they will do? They will rise upward in the cold region. That is, they will come at the topmost layer of the water. While molecules from cold region comes down to take their place. So lower layer or layer lower to the bottom gets heated and comes in the upper surface of the water. Then second layer near to the bottom of vessel, what it will go down, and again this process is repeated. That is, layer near to the bottom gets heated, its density of molecules will decrease, kinetic energy will increase, and they will come up on the upper surface of the water. Each molecule from the bottom gets heated and rises, then cools and descends. Means this process is happening up to that point when temperature of every layer of the water will get same. Okay, this action sets up the flow of water molecules called convection current. You can see when water is heating, you can observe the bubbles. After certain time, when temperature of water is increased somewhat, what will happen, there will be the production of bubbles. You can see on the bottom of the vessel, and you can observe the motion of that bubbles which are produced due to heating in the vessel. So you will understand what is, or you can say, convection current. Convection currents transfer heat to the entire mass of the water. This is what means, first layer is heating up, come to the upper layer or come to the upper side of the vessel. Again second layer will heat up, it will comes on the upper side. Just like that, it's this current is flowing, means this water is coming up after heating near to the bottom of the vessel, and this is what called as a convection current. And by this way, heat is transferred from one point to the another point by actual bodily movement of the heated molecules, and this is happening in the liquids and gases. Okay, so what is the application of convection? So you can see fan which is we are using, you can say this is the application of convection, or you can say heating and cooling of the rooms and cooling transformers, cooling of the transformers. So first we can see here heating and cooling of the rooms. The air molecules in immediate contact with the heater are heat up. In winters we are using mostly in winter season where temperature is too much less, they are using room heaters to heat up the room. So if room heater is on, then molecules near to the heater, what will happen, they will heat up, and these air molecules acquire sufficient energy and rise up. When they heat up, they will go upward, in the upward or near to the ceiling of the room. The cool air at the top being denser and move down and take their places. As this heated air goes up in the room, the cool molecules or cool air at the top being come or down towards the heater or near to the heater, and they will again heat up. This cool air in turn gets heated and moves upward. This whole process continues when your room will acquire some particular temperature. Okay, the same principle but in opposite direction is used to cool a room by an air conditioners. Okay, cooling of transformers. Due to current flowing in the windings of transformer, enormous amount of heat is produced. Okay, so if we have to reduce this heat, so what, transformer is always kept in the tank containing oil. Okay, why we are not using here water, because water is having less boiling point. So if we have kept transformer into the water, what will happen, or air will get, or this is electricity, so water is not good, but current can pass through the water, and due to that we are not using water. Firstly, its boiling point is too much less, so we are using oil, and we kept transformer into the tank containing oil. Oil in contact with transformer body heats up and create convection current. So oil near to the transformer will get heated, its density will get decreased, again it will come up upper side of the tank, and just like this, just how water is heat up, just like this oil is also heat up. Okay, this warm oil comes in contact with the cooler tank, gives heat to it and descends to the bottom. With this process is repeating again and again. This warm oil, the oil, we can decrease the temperature of oil by cooling tanks. So, and again gives heat to that cooling tank, and that oil which is cooled comes down near to the transformer, and this process is repeating again and again, and the cooler tank loses its heat by convection to the surrounding air. And this is all about convection. Now you can say application of convection. Next point is free and forced convection. The convection which happens naturally, that is called as free convection, and forced means which we can artificial convection, you can say. When hot body is in contact with air under ordinary conditions like air around the firewood, the air removes heat from the body by the process. Or you can say land and sea breezes are also formed as the result of free convection currents in air. As I have told you, the convection process can be employing and to create a rapid circulation of fresh air. This is called as forced convection. Heat converter, air conditioners, or you can say fan which we are using in our rooms, heat radiations in IC engine, all these are forced convections. Okay, so next part, which is radiation. Radiation is what? The transfer of heat energy from one place to another via emission of electromagnetic energy without heating the intervening medium is called radiation. So as you can see, for transfer of heat by radiation, no medium is required. So you can take the example of sun. Sun is too much far away from the earth, yet its radiation are coming towards the earth's surface. So there is a vacuum present in between earth and sun. Up to 16 km above there is a earth's atmosphere. After that there is a vacuum, or you can say no medium is present. Yet sun rays or electromagnetic radiation which is emitted by sun comes down towards the earth surface, and this is happening without medium. And first thing, that when electromagnetic radiations are passing in the medium, it will not heat, or temperature of the medium in which they are passing will not increase. Okay, the rapid moving molecules of hot body emits EM waves traveling with the velocity of light. This is called as thermal radiation. Rapid moving molecules of hot body emits, as you can consider the sun emits the electromagnetic waves. These waves traveling with the velocity of light, and this is called as thermal radiation. The radiation which are coming out from the sun in terms of heat, that is thermal radiation. Thermal radiation carry energy with them and transfer it to the low speed molecules of cold body on which they fall. As you can see, when we are going in the sun rays or light sunlight, what will happen? Our body will get hot. Okay, so when thermal radiation will fall on our body or any other material, they will heat up that body. This result in an increase in the molecular motion of the cold body and its temperature increases. As I have told you in the conduction that, or you can say, when any material's temperature increases, molecules in that material will get energy, and whatever the kinetic energy they are having before, it will get increase as its temperature increases. Transfer of heat by radiation is twofold process. Okay, that is the conversion of thermal energy into waves and reconversion of waves into thermal energy by the body on which they fall. Firstly, what I have told you, that sun emits the thermal, that is electromagnetic waves, that is the speed. If rapid moving molecules will of hot body emit electromagnetic waves, that is conversion of thermal energy into the waves. Okay, when these waves are passing in the medium or in vacuum or comes to the earth surface, that reconversion of this wave into the thermal energy by the body on which they fall. This is all about, you can say, radiation. Radiation happens, or radiation is mode of transfer of energy without medium. Means for radiation, medium is not required. Okay, next part is Newton's law of cooling. And this is last point from your lesson. Okay, before this you have studied calorimetry. Okay, in same, that is, you can see here, you have seen what is calorimeter. This one. Okay, same thing we are using in the this diagram, same thing we are using in the Newton's law of cooling. So what we are doing here, calorimeter is filled with boiling water, means 2/3 capacity. You have, means we are not filling it fully. What we are doing, we are pouring water, hot boiling water in the calorimeter with its 2/3 capacity, and it is covered. Okay, thermometer is fixed through the hole in the lid. Whatever the cover we are using, in that cover there will be one hole in which we can put thermometer. Okay, and that thermometer should be, or you can say bulb of the thermometer should be fully immersed in the water. Okay, this calorimeter vessel is kept in constant temperature enclosure or just in open air. Means the temperature of the environment in which calorimeter vessel is kept, it should be constant, you can say, or not changing, or there will not be drastic change in the temperature while doing the experiment. The temperature on thermometer is noted at 1 minute interval. So after pouring hot boiling water in calorimeter with its 2/3 capacity and covered with the lid, then we can fix thermometer through this lid, and we should check whether ball of the or bulb of the thermometer is fully immersed in the water. Then and then only you will get the exact temperature of that water. Okay, after that what we have to do, the temperature on thermometer is noted at 1 minute interval until temperature of water decreases by about 25 degree Celsius. Okay, you can say that when hot boiling water is filled or poured in the calorimeter and we have started the reading, then boiling water is having temperature 100 degree Celsius. After that, if you are taking the temperature of that water from 100 degree Celsius, we have to start and we have to end it at the 25 degree Celsius. Then cooling curve. What is cooling curve? That graph of temperature T is plotted against time. Means you can see in your, this is cooling curve. You can see here this one. So with respect to time, what we have to check or what we have to do with the graph, we have to draw a graph temperature versus time. You will get such a type of graph, such a type of curve which you can see in this figure or graph. Okay, then graph of temperature T is plotted against time T is called as cooling curve. From this graph we can know that cooling of hot water depends on the difference of its temperature from that of its surrounding. So you can take example then daily life also, as if you have boiled the water and kept in the bottle, or just like you have put it into the vessel, whatever the vessel you have used to boil the water, and water is boiled and you have switched off the gas stove. After some time, what you can see, that temperature of the water will decrease drastically up to the, you can say, room temperature, or if you can say room temperature is 40 degrees Celsius, up to 60 degree or 50 degree temperature of water decreases drastically, and after that there will be the temperature change. After this point you can say is less, means if temperature difference between surrounding and water is more, there will be the drastic decrease in the temperature of water. If temperature of surrounding and water is nearly equal, or there is a no much difference, then there will be the less, or you can say slower decrement in the temperature of water. A tangent drawn to the curve at suitable points on the curve, you can see this figure or you can say this graph. The slope of tangent dt by dt, this is temperature, capital T is temperature, T is the time, gives the rate of fall of temperature at that temperature. Okay, as taking 0 0 as origin, if you draw the graph of dt by dt is plotting against temperature difference, as you can see here, there is a tangent drawn at point A and B, right? So dt is what? Temperature difference between A point and B point. dt is what? Time difference at point A and at point B. Okay, so this is dt, and dt is plotted against corresponding temperature difference T minus T0. The curve is straight line, as you can see in your screen. Okay, so what we have observed in the Newton's law of cooling is that hot body loses heat to its surroundings in the form of heat radiation, and the rate of loss of heat depends on the temperature difference in the temperature of the body and its surrounding. Okay, so Newton was the first or first to study the relation between the heat lost by a body in a given enclosure and its temperature in the systematic manner. So what is Newton's law of cooling? The rate of loss of heat. The rate of loss of heat, that is dT by dt of the body, is directly proportional to the temperature difference T minus T0 of the body and the surroundings, provided the difference in the temperatures is small. Okay, so you can write it in the mathematical form, that is dt by dt is directly proportional to T minus T0. And if you remove this proportionality sign, what you can see, that dt by dt is equal to C into bracket T minus T0. And what is C here? C is the constant of proportionality. Okay, so this is all about your lesson, that is thermal properties of matter. Okay, thank you.